Hey everyone, welcome to another episode of Game Dev Assignments. I'm really glad you're here. If you have no clue what this series is about, I'd encourage you to check out the introduction video that's linked below. Maybe I'll put a link to it on the screen as well. But we're just going to jump right into it with assignment 2. I've synced up to the GitHub assignment 2 branch, and I'm just going to read the email. So this is the email from my producer. He says, "Hey Andrew, nice work on the tower placement." That's what we did in assignment 1. "It was intuitive to our playtest group when it was valid or invalid to place a tower. Additionally, we had positive director feedback on the spinning axes. I thought they looked cool too. Next, we'd like to add support for damage text being displayed. In the future, this will allow the player to make more informed decisions by showing them the efficacy of their towers, as well as add a nice visual flair. Some details below." Cool. So we're going to add damage text to the game. I'm a huge fan of damage text myself, so I'm really excited to implement this. The producer's details here say, excuse me, "When an enemy is dealt damage, we'd like text to be displayed showing the amount of damage. The text should be at the location where the enemy took damage. The text should pop in but fade out. New damage numbers should always render over old damage numbers. And if you have any questions, please reach out." So I think that's pretty straightforward, and I have some ideas on how I'd like to do that. I think for the most part, this can be handled, or maybe the easiest way for this to be handled is with a static manager that just handles the list of all of the damage text internally and updating that list, moving the numbers, making them bigger, smaller, fading out, whatever we need to do in the future. And then anywhere where something takes damage, it can just access this static manager, and it'll pass in how much damage to do and where the damage is at, maybe a color of the damage, maybe time to fade, how big the number, whatever details we add in the future. So I've just opened up the project here and I've synced to assignment 2. And once again, if you'd like to start from this exact same point that I'm starting at, go check out the introduction video. It'll explain exactly how to get set up, sync your project to exactly this point so that you can either do this yourself or follow along at home if you want to. So before I get started, I'm just going to fire up the game to remind myself what state it's at. I think I remember for the most part, there's not too much here. We have this level editor mode that you can get to by pressing T, and then you can use the mouse wheel to change between which sort of tiles you're placing. We have this S tile that stands for spawn, this E1 for N, and this P for path. Then if I press T again, we go into the game and things start spawning, and I can place these towers on any of these bricks. I think a tower costs 3 gold. And they just throw axes at the little enemies, and all right, game over. I guess I'm not that good at it. But what we want to do here is when these, and I'll just go out and back in, when these axes hit the enemies, we want to say essentially like intercept where that happens and put a little number on the screen for some visual feedback so the player knows what's going on. Cool. So let's get started. I'm going to start by just adding a new class. I'm going to call it Damage Text Manager. We'll add some include guards here. Maybe GitHub will even be nice enough to add some functions for us. And we may or may not keep them. We'll see. Then we will have, let's see here, add damage text. It's just takes in a number and a position. That's probably pretty good for now. We can say namespace SF, and then we'll include the vector. This is just so we don't have to include this vector in the header. We can just forward declare it. A little bit better for compilation later. And then let's just create some stub functions for all of these things that GitHub has added. I don't know if I'm going to keep them yet, but I think that a lot of the stuff here is pretty much what I want. So although it doesn't do anything right now, but it does seem like what I want. I'm going to add a private, and then I'm going to add a static damage text manager. And this is going to be my static instance of the damage text manager. This will be the only one that ever exists. And actually, what's good practice here, if you're going to have something like this, is to make your constructors private, just so nobody could ever even create a damage text manager. The only time one will be created is for the static instance of it right here. And then additionally, we're going to need to have some sort of struct that encapsulates everything that we need to know about damage text. So I'm just going to add a struct here. I'm going to call it damage text. This is close to what I want, but I actually think what we'd rather have here instead of a damage and a position is we'll just have the SF text here, because the text itself will have a position, and we don't actually care about what the damage number is. We're going to turn that number into a string, and the string is what we're going to display onto the screen. I think it's called SF text. Yeah. So let's add class text here, forward declare the text. Oh, we can't forward declare it because it's an actual instance of it. So I have to include SFML graphics. Probably just want to actually include SFML text if we can get away with it. Is that an option? Maybe it's graphics. If I can spell graphics text. Cool. And then I do think we want a timer just to keep track of, maybe instead of timer, we'll be a little more specific and we'll call it remaining life. Remaining life. That's probably fine. And then finally, we're just going to need a list of the damage text, and we can do that by just making a vector of damage text, which means I will additionally need to include vector up top. And I already think this is a pretty good start here. The next thing I'd like to do is include this in our game somehow. So when we're drawing the game, let's see what draw does exactly. When we draw the game, if we're in play mode, we draw play, which all sounds good. We draw the enemies, axes, player health. I think before we draw the game over text, and maybe even before we draw the tower template, before we draw the tower template, I want to draw all of the damage text. So in order to have access to this, I'm going to need to include the damage text manager. And then I'll need to add singleton access here. And I think that we should be able to just get back a const ref to it. That should be good enough. And then we can call draw, and draw will also be const, because what we can say here is that when we're drawing the damage text, we don't want to actually change any of the underlying text. We just want to display it on the screen. Okay, so over here, what we need to do is we need to say damage text manager. We'll get the singleton instance of it, and then we will draw it to the window. Of course, the window is, I believe the window is just a render target. It is. So what we can accept in the draw here, instead of taking in a window directly, because in the future we might not want to render to a window, we might want to render to something else, we can just say draw, and we will take in a render target. I'm just going to call this render target, and this will be an SF render target. Class render target. Copy. We'll go over here, put this here. And then in our CPP file, we will need to include SFML, graphics, render target. And then what we'd like to do is iterate over all of the damage text and draw them. And we can do that by using a for loop to iterate over a list of our damage text, and this is our struct, if you remember. and one of the struct members is an SF text member, and SF text members can just be passed directly to render targets by calling draw on them. And we are going to render it from the first item in the array or in the vector to the last one in the vector. So that means that everything at the beginning is going to be drawn first, which is probably fine for now. What we can do is when we're removing the damage text, we'll need to keep everything in order, because if you remember, one of the requirements for our damage text is that new damage numbers should always be rendered over old damage numbers, which is probably fine. Maybe what we really want to use, if that's the case, is a double-ended queue instead of a vector, which let's do that. So DEQ stands for a double-ended queue, I'm pretty sure. Anyways, what this allows us to do is pop the members off the front of the queue, draw them, and then put them back on the back of the queue. And this will allow us to do something very specific, which is that the new damage text will always be drawn last, but the damage text does not all have to have the same lifetime, which is sort of interesting. I'm not actually sure if you're able to iterate through a double-ended queue, so I don't know if this will compile. Sorry about that. I suppose I did not realize that vector2f is a typedef, so it's not happy about me namespacing and forward declaring it. So I'm actually just not going to worry about that at all. And I'm going to remove the forward declaration. And then if I really want to, I can just include vector2.hpp here. And then while I was debugging, I got rid of a couple includes to try to narrow down the problem. So I'm going to add back the damage text manager, and I'm going to bring this back in, and let's see if we can build now. And it is still mad. Unresolved. Oh, yep. So if you're going to have a static member like this, you also need to declare it or define it rather, in your CPP file. So you can just do that like this. Semicolon at the end there. And now this should be happy. Cool. And you actually can iterate through a double-ended queue, which I wasn't aware of that being an option, but apparently it is. So we're just going to leave that as is. And then, okay, and then the next thing I'd like to do is implement this update function. And does this actually work? I'm kind of curious. I haven't worked with these for loops that much before. This like new format where you can just kind of do like a for each loop, how C++ or C# does it. I'm not actually sure what would happen if you called pop front and then you go to the next one. I suppose maybe it's fine, because what if you're not at the front? I don't think this will actually work, so I'm just going to delete it. But sorry, not to get distracted. We do want to iterate over everything, but what I'd like to do instead is I'll say we're going to get the count of the queue first. So I'm going to say const int I count, and that'll be the damage text dot size. And then I'll say for int I is 0. I'm just going to start coding this. For int I is 0, I is less than the count plus I. We are going to pop the front. So I'll say damage text. And I'm actually going to get a copy of it. M damage text. Why is it S? Damage text. I would like this to just be non-plural. I think it's a little weird that it's plural. Okay. Still getting a little carried away. I'm going to say damage text dot pop front. And then we will take the damage text and we will reduce its life by some amount of time. I'm going to say remaining life in seconds. I think that makes sense to me. And then what we're going to take in here is, if you remember in our game, when we do an update, if we can find the update play, we have this delta time here that we get every single time we run. And this delta time is probably an SF time. And I think this is what we'd like to take into our update function, so that we just stay in sync with the game and we don't have to worry about having our own internal timer. So I'm going to call this the delta time. In this, we should be able to forward declare. And then I'm just going to copy this and pass it in here. And then I'll need to include time, I'm assuming. Yes. With the Q, you actually say front, and then you can say pop front. So pop front doesn't actually return anything, it just deletes the first element. So what we're going to do is we're going to copy the first element, which maybe is not the best, but I'm not worried about performance right now. We're going to copy the first element, and then we're going to pop it, and then we're going to say remaining life minus equals our delta time as seconds, and now it's mad because we have not included time and we'd like to use its functions. Let's see where it lives. It lives in system, so we can go hash include sfml system time. Nice. And then I'll say this, if damage text, this may be what we want, actually. Yeah. If damage text remaining time is greater than 0, we'll add it back to the queue. Else, we're just going to let it essentially fizzle out and disappear. And then this last function that we need to implement is actually adding text to the queue. So what we're going to do here, and GitHub has set up some stuff for us, but let's see if we like it. It has created a text, set the font to font, set the string to damage, character size is fine, fill color, I don't know why you choose red, that's very silly. The position to position, and then the origin to the center of the text, and then it adds the text, remaining life of 1, adds it to the back. This seems all fine, actually, to me. The only thing that we're going to have an issue with right now is getting a font into the text. Fonts need to live forever, for the whole lifetime of the text, and the text just takes in a reference to them. So what I'm going to do here is actually just look where this font lives in our game. So it's sort of just sitting here. Okay, I thought a bit about this font and how to reconcile it. And what I've actually decided is that maybe for now, let's not overcomplicate things. It's all right if the game's font is not the same as the damage text font. And it might even be true that in the future, we want the damage text to use a different font than we do for the UI. So it's okay that it's separated. It's not the end of the world. But I think that what we might find as we keep going on is that these fonts and maybe even some textures are going to be reused by different systems. And it's not convenient that the font is inside of our game class. It might be better off to live in some sort of other manager class, some sort of texture manager class, where the texture manager ensures that we only have one instance of any of our fonts loaded, and we're not double loading the fonts and just sort of wasting space. But that's okay for now. What we're going to do is we're just going to say the damage text manager has its own font, and we'll need to include font then. So let's see where font is defined. I'm assuming it's graphics. It is. So we will say hash include sfml graphics font. And then in our constructor for the damage text, we just want to load the font. And we're just going to use the same font that we're using for the UI, which is this Crayon Medium TTF. This should be on the GitHub as well. And then when we're setting the font, we set it to the font. We set the string, set the character size, origin, damage text. Okay, everything seems to be mostly set up. The only thing we need to add in here is in our game, when we update play, we have this delta time. We will need to update physics. We check for deletion requests. We will additionally, time and play mode, we will additionally need to update the damage text. And so this part's kind of interesting. This iPlayer health is less than or equal to 0 is an early exit when we're in the game over screen. I think that when you're in the game over screen, it actually makes sense for the damage text to just sort of remain there. So what I'm going to do is right after the this check to see if we're essentially in the game over screen is when I'm going to call the damage text manager update, and I'm just going to pass in the delta time. Of course, I can't just call update. I need to call get instance dot update. Of course, we need to add a new getter. I'm going to call this old getter the const, and I'm going to call this one non-const. I know this might seem a little overkill for a single developer project, but this sort of stuff can really help you out in the end, just to keep const calls and non-const calls separate. So when we update the damage text, obviously we're going to be changing the internal state of the damage text manager, so we want to get a non-const reference to it. Okay. I believe that pretty much everything is set up. The only thing that we're missing is actually adding damage text. So if we look at our entity and how they take damage right now, let's see here, let's type in damage. We get called deal damage, and then we just take some damage. So what I'm going to do is I'm going to move our deal damage text into the CPP file, which is probably where it should have been from the beginning, I know. And then I'm going to say, let's see here. We probably only want to see, so health is less than or equal to 0. Do we want to see damage appear if the enemy is already dead? It's an interesting thought. I'm going to say yes, because you'll see more stuff on screen. So if 2 axes hit an enemy in the same frame, you'd see, and the first one kills the enemy and the second one just hits them. Why not? Why not just see both instances of damage text? So I'm going to do up top is I'm just going to say, somehow I've clicked insert. I'm going to say include the damage text manager. And then when we're dealt damage, we will say damage text manager, get instance non-const, because we need to add to an internal array, and we're going to add damage text, and the amount of damage is going to be the damage that we're taking, and the position that we want to draw it at is just our position. That's probably fine. So let's see if this compiles and runs. Okay, we've compiled. Let's run it. I'm just going to do my basic setup here. Start here, end here. Here's your path. I'll put some guys in. And yeah, it looks like it's working more or less. So we have the damage text popping up. It looks to be just centered on the enemy, which isn't too bad. But I would say that we're missing some of the implementation details right now, as well as just as a developer and as a person who plays video games, I can tell that this is not going to get good feedback. This is just kind of weird right now. There's numbers popping up, but it doesn't feel like the damage text that I want. Also, they're seemingly a little bit blurry. I actually think that the blurry issue may have to do with the integer alignment. So if your damage text isn't on even integer, sometimes it has to be like anti-aliased. But I'm not going to worry about that too much right now. What I'm going to do is refer to the email, because this is what I was told to do. So when an enemy is dealt damage, we'd like the damage to appear on screen. Done. The text should be at the location where the enemy took damage. Pretty much done. It appears on the enemy instead of where the axe hit the enemy. But I actually think that maybe what they want anyways, the text should pop in but fade out. We do not have this right now. So let's work on that first. So look at the damage text manager. When we're updating, what I want to do is get a float for percentage through life. which will be the remaining life divided by 1 second, because that's the amount of life we start with. And I'm actually just going to add here, I'm going to add a static float, and I'm going to call it damage text life in seconds. I'm going to set this to 1. And the reason I'm doing that is because I'm starting to have these kind of magical numbers that are just lying around, and it's not obvious that they should be kept in sync. So it's easier if we just create a variable and make it very obvious that that is what we want. And if we want to declare it in the header, we'll need to have it as const, or you can make it const expr. It's going to be the same difference if you're using C++, the newest standard, C++ 20 or something. And I might even be happy with that in C++ 11, to be honest. So we find this percentage through life. What we can say is, well, actually, we don't need to do any of this unless we're still alive. So we're going to go inside here. We'll say percentage through life. So if our remaining life is greater than 0, we're going to find a percentage through life. And then we're going to make a color. We're going to get the fill color. And then what we're going to do is we're going to set the alpha of the fill color to 255 times the percentage through the life. And that's because the colors are just 4 8-bit integers. So the maximum value there is 255. And what we want to do is find the ratio of what that number would be. So we take the max value, 255, and we multiply the percentage. And what this should do is that over the lifetime of the text, it'll start off as fully opaque, and then it'll become more transparent as it disappears, which will more or less get us the requirement of we want it to pop on screen and then fade out. So let's check that out in game real quick. Do a little spawn, show a little path, and some guys here. I'm going to say that it's not fading out. Okay, let's do a little bit of investigating here. Oh, duh. So if we if we get the color, we need to also set the color. So I'll say damage text dot text dot set color, and we'll set it to the color. This will now work. I'm pretty sure of it, so I'm not going to check quite yet. I'm going to add some comments here. I'm just going to say fade out the damage text over time. And then I think that I would like it to pop a bit more. And what we can probably do to make it pop a bit more right away is just to increase the character size. Real quick, though, what I'm going to do is just look at the TTF file to see what kind of sizes we have available. So 36 is a good character size, I think. 36. And then there's some other things that are built into SF text that I think we could utilize. So you can do set outline color. And we're going to set this to black. And we can also set the outline thickness. So I'll set the outline thickness. And I think I'm just going to set this to 2 right now. I'm not actually sure what exactly it'll look like. But what I'd like to do is this will help the text differentiate from the background so that you can actually see it very well. So let's see if this is all working. Set color was declared deprecated. So how do we set the colors? Oh, set fill color is what we like to say. Okay, no problem. Looking at this in game now, I'm just going to create start and path. Put some guys down. Let's look at this. Okay. Looks like it's like fading. Yeah, this isn't terrible. It's a little weird. Oh, I think that what we're actually going to need to do is, in addition to fading the fill color, we'll probably also have to fade the outline color. It looks like the outline is actually sticking it's not just an outline. It looks like it actually is kind of like a fill, but just like a bloated fill. So let me do that. I'm going to say SF color, and I'm going to call this outline color. And then I'm going to do the same thing for my outline color. And then I'm going to set the outline color here. I think this should look just a little bit more natural. Okay. Get a start and end path here. Okay, that does look just a little bit better. Neat. And I think this really is more or less the entire requirement. Let's see here. New damage should always be rendered over the old damage. I believe that is true, although it's a little hard for us to check right now. But just because everything gets added to the end of the queue, and then we render the queue in order, everything at the back should be rendered first. So it should be good to go. And you know what? I'm actually going to stop this one here. I'm not going to get too carried away. Trying to keep this a little more concise than the last assignment, which really took me a while to do. It was a big assignment. So thank you so much for watching. I really appreciate it. If you leave a comment, like, subscribe if you want to see more of this. And yeah, thanks so much. Take care.